It will echo for a few minutes and hopefully it'll stop. Okay, we're going to start with Pascal's triangle, and I know we've done this before. So here we go. The triangle is formed by beginning and ending with a 1, and then you just add the previous two numbers. Again, every row begins and ends with a 1. Now it starts with a 1, 1, 1, and then look, to get the middle one, you do 1 plus 1. Here, it begins with a 1, then you take 1 plus 2 is 3, 2 plus 1 is 3, and it ends in a 1. So begin and end in a 1, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, end in a 1. So the next row is going to go 1, 5, 10, 10, 5, 1, like that. All right, can you go ahead and try the next row? Try the next one on your own paper. And Abby, what are you getting? Tell me your row.
1, 6, 15, 20, 15. 1, oh, 6.
6 and 1. All right, you got it. Okay, so this is one thing that Pascal came up with was the Pascal's triangle. But here's the really cool part. I want you to look at my exploration. If you have x plus y to the 0 power, that's just 1. And if I have x plus y to the first, that's 1x plus 1y. And I do want you to write it like this because I'm going to make a connection here. And if I have x plus y squared, that was 1x squared plus 2xy plus 1y squared. If you remember back to Algebra 2, I had given you a formula for x plus y cubed, but some of you refused to memorize it, and you just kept multiplying it out. And now I'm going to go ahead and write it out, and then I'm going to explain how it is connected to Pascal's triangle. What I want you to look at is that letter A is actually row 0. We call that top row, not row 1, but row 0, because then it makes a beautiful connection to binomials being expanded, and so on. This could be row 5 and row 6. So look, x plus y to the 0 is 1. X plus y to the 1, if I look at row 1, is 1, 1. Then this is 1, 2, 1, 1, 3, 3, 1. These are actually the rows of Pascal's triangle. Now watch, I can do the x plus y to the 4th by making it 1, x to the 4th, 4, and it's x cubed y, plus 6, x squared y squared, plus 4, xy cubed, plus 1, y to the 4th. So if I look at that row 4 of Pascal's triangle, here's the 1, 4, 6, 4, 1, and then there's a pattern with the variables. It goes x to the 4th because it was to the 4th power, then x cubed y, x squared, xy cubed, y to the 4th. Okay? So I felt like I was cheating last year in Algebra 2 when you guys were all multiplying it out, and I'm like, I already know how to do this. So let's go ahead and add one more, and I want you guys to expand it now with Pascal's triangle.
It's legit.
Okay.
For the letter E, can you just like count down like the x to the 4th, x to the 3rd, x to the 2nd, x to the 0 with?
Yes, that is the pattern.
And then the same way, and then the y, you start at the end and then you count down.
Yes.
Oh,
that is the pattern.
See, that was legitimate.
Maybe the board.
So what you can do is like this. You could go 1, 5, 10, 10, 5, 1, and then insert your variable. So that'll be x to the 5th, then an x to the 4th y, an x cubed y squared, x squared y cubed, xy to the 4th, and then you have a y to the 5th. Okay? All right, now go ahead and look at the next example, and you might want to draw a triangle for your Pascal's triangle, and just draw an arrow over to it. Try example 1, letter A. X plus y to the 6th power. Use your 6th row. Then don't work ahead on letter B. I'll need to help you with that. While you're working, this is a one-day lesson. I thought it was going to take me 2, but we zipped right through it, and I didn't go quickly. So we have a quiz on Wednesday then. Tomorrow will be a review day on 9495 with the quiz Wednesday. All right, for letter A, did you get 1x to the 6th plus 6x to the 5th y plus 15x to the 4th y squared plus 20x cubed y cubed plus 15x squared y to the 4th plus 6xy to the 5th plus 1y to the 6th. Okay, pretty straightforward.
Yeah.
Now, it's going to get just a little bit more complicated in letter B. In letter B, I have 3x minus y to the 5th power. So what I would recommend that you do is let's list the coefficients, but leave some space. Okay, like this. So make a 1, 5, 10, 10, 5, 1. That's the 5th row. Now, what you're going to need to do, if it's something other than x and y, you have to put that term in there. So watch what's going to happen. This is going to be a 3x to the 5th. And then I'm going to go 3x to the 4th times, and if there's a minus sign, instead of trying to learn a second formula, we're just going to take the minus sign with the second term. Then it's going to go 3x to the 3rd negative y squared. I'm sorry, I don't know why my pen is not working so well. Okay, then I'm getting 3x squared negative y cubed. Then I have a 3x to the 1st and a negative y to the 4th plus, and then I have negative y to the 5th. Then you are welcome to use your calculators here and take 3 to the 5th. So that's 243x to the 5th. Now think about your signs here. A negative y to the 1st is going to make that negative. So I'm just going to make this a minus sign. You need to do 3 to the 4th and then multiply by 5. And so I got a 405, and that's x to the 4th y. My negative y being squared would be a positive. So 3 cubed is 27 times 10, so that's 270 x cubed y squared. You will notice that a minus sign, if you're doing a difference in your binomial, does just make the signs alternate. And then I got minus 90 x squared y cubed plus 15 xy to the 4th minus y to the 5th. All right, questions on letter B? All right, what I want you to do is I want you to flip the page, and I want you to try example 2, A and B. Just, we're going to do it with Pascal's triangle, so just expand both of those. Okay, go on to example 2, and we're going to do that with Pascal's triangle.
Oh. There's 2 examples.
Oh, sorry. The one that says use the binomial theorem to expand. I'm sorry.
It's like Miss Magdalene. I was like,
You're like, what? Oh, you're right. That does have 2
Yeah, I was
example
like-
cues. That's my bad. Sorry. Do this one. Whoops. Oopsie daisy. So x minus 2y to the 4th power. That's my bad.
I forget.
Okay, if you have letter A, I got x to the 4th minus 8x cubed y plus 24x squared y squared minus 32xy cubed plus 16y to the 4th. Like I just stated, if you have a difference here instead of a sum, your signs just end up alternating. That's all. Questions on letter A? Now B is going to be more difficult because you have an x squared that you're raising to a power. Does everybody have part A so I can erase it? Alright, then go ahead on to B and I'll work that out in a moment. So that's to the 3rd power, so you're going to go 1, 3, 3, 1. Alright, letter B, when you're ready, you do your 1, 3, 3, 1. Then it would be x squared being cubed, x squared being squared times 4 to the 1st. Then you have your x squared to the 1st, 4 squared, and then a 4 cubed. So remember, a power to a power, you multiply the exponents. So my x squared being cubed is x to the 6th. Okay? Alright. Now, we have the binomial theorem, and the binomial theorem gives us this NCR. And it says that NCR equals n factorial over n minus r factorial times r factorial. So let's do a quick example with this. If I do 5c2, you would get 5 factorial. Now 5 minus 2 is 3 factorial times 2 factorial. If you remember in the beginning of the chapter, we worked with factorials. Well, they're not going away, and we're going to keep using them. We're going to move into probability, and we're going to move into combinations and permutation. So the C represents a combination. So suppose there's 20 people in NHS. And the school has decided to take 3 people to a conference. Well, if they're going to send Betsy, Nathan, and Abby, it doesn't matter the order that we group the 3 of them, and that's called a combination. But let's suppose that with NHS, they're trying to select a president and vice president. It makes a difference whether it's Sam or Ian, Sam as the president and Ian as vice president, versus if Ian's president and Sam is vice president. That's two different arrangements where the order matters. So, later in this chapter, we will be dealing with permutations and combinations, but for now, it's giving us these coefficients, and so we're going to learn how to work with them. 5 factorial is equivalent to 5 times 4 times 3 factorial, and so I can get that to cancel with the 3 factorial here, and notice there is no reason to use your calculator. 2 goes into 4 twice, and 5 times 2 is 10. Oops, sorry. So, your 5 times 2 is just the 10, okay? Now, it says this symbol here, and oftentimes we read it as N choose R. N choose R. I don't know why my pen is acting up here, but N choose R is the same thing as NCR. It's like you have N objects and you're choosing R at a time, okay? So, in example 2, the first example 2, if I have 8C2, that's 8 factorial, then you take 8 minus 2, which is 6 factorial, times the 2 factorial. I'm just using the formula above. Now, if you're getting really advanced with this, if you can tell that you're going to cancel the 6 factorial, you are welcome to do that in your head and make it 8 times 7 over the 2 times 1. Do you see how I canceled my 6 factorials? Then 2 goes into 8 4 times. 4 times 7 is just 28. Now letter B, this is just a different notation for the same thing. This is saying that I have 10 choose 3. So it's 10 factorial over 7 factorial times 3 factorial. So, I can make this 10 times 9 times 8 over 3 times 2 times 1. 3 goes into 9 3 times, 2 goes into 8 4 times, so that's 120. All right, try C and D on your own. So in C, you should be getting 7 factorial over 7 factorial times 0 factorial. What do you know about 0 factorial? It's 1. So, and the 7 factorials cancel, so that's 1. Then 8 choose 8 would be 8 factorial over 0 factorial times 8 factorial, which is still 1. Now you might want to write a note down here. If you have n choose n, that's 1, and n choose 0 is 1.